So now we're going to talk about the muscle stretch reflex, sometimes referred to as the deep tendon reflex or DTR. So this is an example of a spinal cord reflex that we can depict as a feedback loop. So if we start with the muscle length as the controlled variable, we know that if the muscle length increases and there's stretch, the muscle spindles, which are inside the muscle, they get stretched and send information to activate lower motor neurons that are found in the anterior horn of the spinal cord. The lower motor neuron releases acetylcholine onto nicotinic receptors, which triggers ultimately skeletal muscle contraction, which is a shortening of the muscle, lowering the muscle length. So you can see that this is a negative feedback loop. There's one inversion, and we have a stabilization of the muscle length. If you hit the tendon, you actually increase the length of the muscle, and we're going to take a look at this in a second, but that's the outside disturbance, lengthening the muscle, increasing muscle spindle stretch, activation of lower motor neurons, and then contraction of the muscle. Now, before we look at this in a little bit of a different way, I want to look at the reflex arc using the terminology of the afferent limb of the reflex arc, and that would be the sensory input into the spinal cord. So we have it going from the peripheral nervous system to the central nervous system. That's why we use the term afferent. And then we also have the efferent limb, which would be the lower motor neuron releasing acetylcholine onto the skeletal muscle, causing skeletal muscle contraction. So all reflex arcs have an afferent limb and an efferent limb. So let's take a look at what this would be if we take a cross section of the spinal cord, and we can see that we have the back of the spinal cord, the posterior, the front, the anterior, we have left and we have right. And now what we're doing is we're hitting the patellar tendon on the left side. That's going to activate these muscle spindles in the muscle, stretch them, and now we're going to get information is going to go into the spinal cord. We have the dorsal root ganglion, which is the cell body. We're still going to have that information go in like this and ultimately cause an EPSP right here on that lower motor neuron. And then we're going to end up with acetylcholine released onto the muscle, causing skeletal muscle contraction. So I want to point out a couple of other things here, that if there's a disruption in the reflex arc, the reflex is not going to work. So that means that if there's a problem with the afferent limb, even if the motor neuron here is intact and is able to release acetylcholine, loss of the afferent information will prevent the reflex arc from working. Similarly, if you have the efferent limb of the reflex arc disabled, again, you will not be able to have the reflex arc. Now, there's also some other controls on the reflex arc here that's not shown. The central nervous system from above sends down inhibition on the reflex to tone it down typically, and when we have lesions that affect some of that descending input, we can end up with increased reflexes.